Dear ICACSIS Committee 2020, IEEE Indonesian section, and all participants in the 12th International Conference on Advanced Computer Science and Information System. Okay, first, imagine we have a coffee shop. One time, a customer came to our shop and bought a cup of coffee. We should be presenting product that customer order and conveying information related to this product. Then, imagine if it turned out that the coffee we serve, according to the customer, doesn't taste like the information previously obtained. Customer want reliable product traceability information. The question is, what kind of traceability information system should be built to give trust to the customer? On this occasion, I am Gusti Pradana with Mr. Topik Jatna from the Department of Agroindustrial Technology and Mr. Irman Hermadi from the Department of Computer Science, IPB University Bogor, Indonesia, will present potential idea on this subject with a paper entitled Blockchain Modeling for Traceability Information System in Supply Chains of Coffee Agroindustry. Here is the outline for my presentation today, starting with the introduction, then related work, methodology, and then the result and discussion section. Finally, I will show you conclusion and suggestion for future work. Let's start with the introduction section. The traceability system basic idea is a tool to track where a particular item is located and trace its history. This system is one of the most critical requirements in supply chain information system, especially risk management and quality control. Food safety and quality assurance are considered vital in traceability for the stakeholder in any logistic and supply chain organization. The traceability system is required to uniquely identify incoming material from the upstream supply chains to the final product's distribution route to the end customer. However, in the real world, the traceability system has the risk of changing the product information presented to the end customer. There are several important information on its cup of coffee, such as origin, harvesting process, cherry bean processing, green bean processing, and the roasting process. If there is any falsification of this information, for example mixing the coffee origin, it will invariably give a significant change in taste to the final coffee product. Thus, the transparent data is needed so that falsification on information cannot occur. This will keep customer loyal and trusted. Realizing data transparency to customer requires the use of existing technology to turn existing challenges into profitable opportunity. Blockchain technology is a ubiquitous ledger of record, secure with distributed storage and cryptographic validation, and doesn't require the third-party authority in each of its transactions. With its capability, blockchain technology can be utilized as a technology base in the traceability system. From the explanation above, we draw a problem statement as follows. First, what is needed to develop a traceability system in the supply chains of the coffee agroindustry? And the second, how to design a traceability information system prototype based on system requirement with blockchain technology. Several opportunities have been presented to utilize blockchain technology in various industrial sectors, including logistics, supply chains, and agriculture. In agricultural products, blockchain was proposed as an effective solution to link legal documentation and attachment of Industry 4.0 in the such system. This can be seen in the research of several commodities such as wine, honey, egg, soybean, cocoa, and chocolate production, etc. In the study of Sender et al. 2018, blockchain technology shown a significant influence on customer purchasing decision. In the same year, Tiruchelvam et al. Tested blockchain technology readiness if applied to the coffee supply chain trade with a case study on Burundi coffee. Last year, Casino in his paper suggests that blockchain for food supply chains can increase efficiency, responsiveness, food quality, and trust. In addition, Hello and How have tried to make blockchain modeling a solution for tracking package in the supply chain. However, there has never been a paper that fully discusses traceability information system modeling using blockchain technology from the previous discussion. This is what will be answered in this paper. Next, to the methodology. There are three objectives we want to answer in this paper. Start from the objective 1, we start by analyzing the requirement for traceability system, and then analyzing the actor in coffee agro-industry supply chains, and then analyzing the top picture that show product quality. And after that, in objective 2, we design the data inputting process system, transaction process, and traceability process. In the last objective, we do prototyping, validation, and verification of the model that has been made. There are three results shown in this paper. First, we offer the results of requirement and actor relational analysis and also product quality measurement analysis. Second, we will deliver the inputting data process, transaction process, and traceability process. Finally, we will present a prototype of the application. Let's start with the first result. This is the result of requirement and actor relational analysis. The requirement to create a traceability information system in the coffee agro-industry are shown in the system entity. Furthermore, the actor involved in the supply chains can be seen in the use case diagram. In selecting the coffee quality assessment feature using WCA, three top attributes have been obtained, as shown in the figure. After that, the three components were made a dataset and tested for similarity. You can see on table 1. In data input process, we ongoing process is shown by the BPMN diagram. The data collected in this process is shown in the table. Furthermore, in the transaction process, several stages occur, which are shown in the BPMN diagram. Transactions that occur will be recorded and stored in a block. The blocks are related to each other, so the data has been saved, cannot be changed, and can be seen by all parties on the network. As shown in the image, the transaction code will be stored with cryptography and hashing algorithm, so that with this data, information on product can be traced. A smart contract as agreement by the actor is shown in the example solidity code. In the traceability process, we scan the product we want to trace first and wait for the results for a while. In this process can be seen entirely in the BPMN diagram. The tracing process can be done using the decision tree algorithm approach, as shown in the figure. The transaction code, transaction ID, the actor involved, block number, and timestamp can be seen clearly in the table. This is the logic used in the copy product tracing process, as explained earlier about the decision tree. In addition, we also provide pseudocode to enter a logical program that will run on the copy agroindustry traceability information system. Finally, we did prototyping of the copy product tracing application based on the previous component. Requirement analysis and actor relational analysis have formed the basic frame of system requirement and relationship between actors. Furthermore, quality measurement analysis is shown through product quality information as follows. Necessary information about product is input into the input process by the upstream actor, the farmer. Finally, traceability information can be present with the process that is recorded in the block with cryptography and hashing, which is shown as follows. After our explanation has been complete, we would like to point out the research strength and weakness. This research clearly shows the system requirement, the relationship between actors, and translate several essential components in the traceability information developed in the system. However, in this paper has not yet explained in detail the stage and the process of creating a blockchain-based traceability information system, such as making smart contract between actors in the copy agroindustry supply chains. Okay, this is conclusion and future work. First, in the conclusion, the system entity diagram can point the requirement, and the use case diagram can show the relationship between stakeholders in the copy agroindustry supply chains. The main component of copy quality indicator can show with relief and similarity algorithm. Second, the input, transaction, and traceability process has been able to model the required traceability information system. Blockchain technology with cryptography and hashing has shown how data can be transparent and irreversible. Role in the tracing process has been demonstrated using a decision tree and pseudocode algorithm. And the third, the prototype of traceability information has been presented the attribute whose customer need. For the future work, I suggest to conduct research focusing on how transaction between two entities can occur in their entirely. And the second, the mechanism for changing all contract into smart contract, detail of possible agreement, working mechanism for smart contract and consensus are some topics that can be worked on. Okay, that's all of my presentation. Thank you.